Assalamualaikum warahmatullahi wabarakatuh. So in this lab 6, we student learn the Ziegler-Nicholas method. My name is Muqri Bin Mohd Yusli. So the objective of this experiment 6 or lab 6 is student should be able to produce P, PI, PID or PID step response using MATLAB command. And the other one is student should study and determine the value of P, PI and PID using Ziegler-Nicholas method. So this is the introduction of the lab 6. We go to the MATLAB command. So the MATLAB command here has 5 command, which is the student need to use this command to be able to get the graph of P, PI and PID. So the first MATLAB command that students need to use is, if student want to generate transfer function system, then student should include this command in the MATLAB. So GP is equal to transfer function NUM comma DEN, which is NUM is the numerator and DEN is a denominator. The second command is, if student want to generate the system feedback into a system, the student need to use this system equal to feedback GP per H, where H is the system feedback of the system. Then the third command is, if we want to produce the system graph, we should use this command, stat open system R minus. What is R minus? R minus is color of the line graph. The fourth one is, if we want to add PID to the, this is the command, C is equal to PID and KP, KI and KD, where KP, KI and KD is the value of PID respectively. And the last command is, if we want to generate the system feedback with PID controller into a system, we should use this command, system PID is equal to feedback GP, which is our transfer function, and H. So the exercise, student need to calculate by themselves, which is controller is a K and this transfer function. So this is the calculation, and the final answer we got is KC is equal to 10, PCR is equal to 1.89 second, and the omega is root 11, which is the value is 3.32. So let's look at on how we want to produce graph. So this is the simulation. If we want to get the transfer function, if we want to get the graph, so let's look at the graph number 1, which is step response. So the command we include here, the value we put in here is the value that we calculate from the calculation. So let's run the command step response. So this is the step response command. Student need to click on characteristic and tick on the on data that they want to see. As I click just now is peak response. So this is the peak response of this graph. And the second one is setting time. So the setting time is here, which is the setting time is equal to 3.68 seconds. and the rise time of this graph is 1.15 second, and the last one, the steady state, is find the value of the system is 0.5. This method is applied to all the graph that we wanna look. Example, this is the result that we get, that we do just now. This is the value of P, PI, and PID that we get from the all observation. This is the whole graph result, P, PI, and PID combined into one graph plus transfer response plus time response. And then let's look at the P graph. The P graph is the coding of the P graph is here. So let's run it. So this is the P graph. We tick on the every characteristic that we want. We could see this is the step response that we just calculate just now. Just look at the red line. So the red line is a P graph. So the rise time of the P is 0.505, and the overshoot is 54, which is 55% at time 1.4 second. And this is the last one is here is the steady state, and the setting time is 9.01. After that, same step, go to PI here, we run, then we get the graph, we look at all the characteristic. So the rise time of this PI is 0.536, and the overshoot, it overshoot 63% at time 1.53. The setting time of this PI graph is 17.7, and the steady state is 1. So let's look at the PID graph. This is the PID graph. The steady state is 1. The setting time is 4.06. The rise time is at 1.16 second, and the rise time is 0.5. So the combination of P, PI, and PID should use this command, step system G, R, B, and Y. Run the project as, so we can see this is the P, PI, and PID graph. Look at this graph, we can compare the graph. What the comparison between this P, PI, and PID. So as we see here, the blue one, the blue graph, the is overshoot, get more overshoot, which is not suitable in this system. The red one is the most suitable one. So list all the result here, and this is the last last data that we get from the experiment 6. That's all from me. Thank you.